Okay, give the coordinates of a vertex that is equidistant to 4 sites. So remember just a couple seconds ago, I said almost never are you talking about 4 sites. You're almost always talking about 3 sites and being equidistant from 3 sites, right? So if we were to zoom in on this diagram right here, being equidistant from A, E, and J, we need to focus on that triangle and find the circumcenter from that triangle, and that would be this point. Whereas the circumcenter for AEK would be this one down here, so refocusing. So we can see that pattern and we can recognize that it's most of this diagram. Now we need to look for the outlier, look for the thing that looks kind of not like the other ones because it doesn't follow the same pattern that we typically see. So we're trying to find a point that is equidistant from 4 points, and that is this point right here. Notice it looks different than all of our other points coming together, and that we can then look to all of the perpendicular bisectors that shoot out from here, and there's 4 different perpendicular bisectors that shoot out from this point, whereas look at your other points, they're called vertices. Look at the other vertices of your cells, and almost all of them, if not all of them, have 3 perpendicular bisectors that come out. So since there's 4 that come out of here, that means it's equidistant from 4 points, and those 4 points are G, M, C, and F. So it says give the coordinates of a vertex that is equidistant to 4 sites. So we're going to go ahead and look at that. That one's pretty easy to see, easier than some of the other ones, and it's 25. So if I'm standing there, I could ping off from all 4 cell towers. That's the only place I would ping off of all 4. Okay. Estimate the coordinates of a point equidistant to sites A, E, and K. So estimate the coordinates because this one is not as easy to see. So going to A, E, K, which we already did, that was the orange dot that we put in. So I'm going to that looks like it's just above 25. So I'm going to say that it's 26 on the y-axis. And then following that point down, maybe 20 on the x-axis. It's really fuzzy, which is what happens when I'm copying it from the book. But yeah, I would say that the x value is 20 and the y value is 26. So I'm going to do 20, 26 as my estimate here. Explain why the diagram cannot give us a point equidistant to site C, F, I, and L. C, F, I, and L. So the reason why this diagram cannot give us a place that is equidistant from all 4 of those points. And then it's going back to what I said about it being equidistant from 3 points typically and almost never 4 points. So 3 points can happen because any 3 points that you can create will lie on the same circle. If you do any 3 points that you can think of on your paper and you connect them to make a triangle, there will be a circle that exists that includes all 3 of those points. When you start adding more points, and the reason why that works is because of the behaviors of the circumcenter. So finding your perpendicular bisectors, they will always meet between 3 points. It will not always happen with more than 3 points because they have to lie on the same circle. And when you start adding 4 or 5 or whatever, however many points, they will not necessarily lie on the same circle. So looking at C, F, and L, or CF and I, B is getting in the middle of there. B is creating this interruption into the cell that could be CF, L, and I. I wanted to focus on CFL, and CFL does not have a point that's equidistant between those 3, and that's also because of B. If we were to get rid of B and try and think about the perpendicular bisector between C and L, because there's a perpendicular bisector between C and F, there's a perpendicular bisector between F and L, but between C and L, that's a terrible one. But between those guys, you can see that since B is being introduced, that all the cells that are created are already being taken care of in terms of the closest cell or closest site. So there's multiple answers here. C, F, L, and I do not lie on the same circle, so you cannot find one point that is equidistant from all of those. Also, with site B is a site that's closer than I, and so no matter what, B will be closer to C, F, and L than I ever will. The cell that contains I doesn't even touch any of the vertices, right? The cell that contains I doesn't even touch the cell that contains C, and that's the closest one. So we're going to write down something like C, F, L, and I do not lie on the same circle. So this idea of being equidistant from all those points is that there's a center somewhere of a circle that would connect those 3 points such that it would be equidistant, because circles have a radii that always stay the same. So we would always have a circle that encompasses those 3 points, and I does not lie on the same circle that includes C, F, and L. So, okay. The first reason is that C, F, I, and L are not contained on the same circle. And the second reason is that site B, or the cell that contains site B, will always be closer to C, F, and L than I will ever be. Okay, the point AA is equidistant to site J and N. Find the value of A. So there is a point, and using both the same variable for both X and Y means that they'll be the same number. So equidistant to site J and N means it will lie on the perpendicular bisector that separates J and N. So we need to find the perpendicular bisector that goes between J and N. So here's J and N. We need to find the coordinates of both J and N. Then we need to find the perpendicular bisector between J and N. So let's first find the coordinates. Let me just pull them from the textbook. Okay, the textbook does not give us the coordinates. It just gives me the answer. Okay, so the coordinates of J are 40. So 30, 40 is J. And N is 34, I think it's 34, 48. So to find the equation of the perpendicular bisector, so let's dig into this because we haven't done it. Well, we did do this a long time ago. Perpendicular bisector has two pieces. First is that it bisects, so it goes through the middle, so we need to find the midpoint between J and N, and then it is perpendicular to the segment that connects those two. So we need to find the perpendicular slope, so we'll find the negative reciprocal of the slope, and then we need to find the midpoint and then create the equation of the line. So the slope between those 2 points is 48 minus 40. Remember, rise. So your y value divided by 34 minus 30. So that's 8 over 4. So that's 2. Which means that our perpendicular slope will be the negative reciprocal. So negative 1/2. We also need to find the midpoint. So we'll do MP. Remember that midpoint is the average between your two values, right? So it's the average of your x values and the average of your y values. So you add the two numbers together and then divide them by 2. So for your x's, it's going to be 32. For your y values, halfway between that's going to be 44. Okay, so it's got a slope of negative 1/2 and it's got a point of 32.44. So the equation, I'll do it in a different color, is y minus y1, which is 44, equals m times x minus x1. These are all things that we've learned in the past, so now you're expected to know them. I should not have to readdress them. If you need a readdressing of them, you've got tons of resources available to you, the whole internet. Okay, so finding the coordinates of which both x and y are a, we're going to plug in a for both y and for x. So I'm going to go back into here and do a minus 44 equals m times a minus, it was what, 32? Yeah. And then solve for a. Do it algebraically or use your calculator. Just for expediency's sake, I'm going to do my numerical solve. X minus 44 equals negative 0.5 times x minus 32. And we get that a is equal to 40. So the coordinate that is equidistance from both of those has to lie on the perpendicular bisector. So you needed to find the equation of the perpendicular bisector, which we did really quickly. And then it was the fact that both of those guys were the same variable, so that had to be the same number, and then you just plug it into the equation of your perpendicular bisector and solve for what point would have to lie on that perpendicular bisector and have the same values.